TypeScript is surprisingly okay for compilers. My general thought is that they're going to be talking about the type system, and it's the fact that you could just do these basic like union types, type discrimination, right? You kind of have tagged unions in TypeScript, you know what I mean? You kind of have it. You just have like a type that's a string. I use it all the time. It's also kind of a pain in the ass. There are two main historical trends when choosing an implementation language for something compiler shaped. For more language sector tasks, like a formal specification or a toy hobby language, OCaml makes most sense. Let's go, OCaml. We got an OCaml shill in the house. For example, see Plazoo, WebAssembly reference interpreter. For something implementation-centric and production-ready, C++ is often chosen. LLVM, Clang, V8, Hotspot are all C++. These days, Rust is a great new addition to the landscape. It is influenced most directly by ML and C++, combines their strengths, and even brings something new of its own to the table, like seamless, safe, fearless concurrency. Still, Rust leans heavily towards production readiness side of the spectrum. Classic. I believe what I just heard here is that production readiness spectrum is how far away you are from Haskell. So what I'm truly hearing from this is that there's this thing called Haskell. It is in the center. This means you are not ready for production. Then there's like, then you got like, I don't know, you got like some Lisp in here, maybe some OCaml, and now you're really not ready for production. Then you have like Rust, right? And now you're pretty close to production, okay? And then on the outside, you have like C++, you have TypeScript, you have Go, you got Python, you got like all the languages out here. These are production-ready systems, okay? It's kind of like Idaho, or not Idaho, Ohio. You're either in Ohio, you're threatened near Ohio, or you're just in disillusionment that you're not threatened by Ohio. This is pretty much the same thing, except with functional programming at the heart of it. So Haskell being the least production ready, Go, C++, TypeScript, and Python being the most production ready. You get the idea? I think you guys get the idea. While some aspects of it, just works build system, help with prototyping as well, there's still extra complexity due to attacks due to the necessity to model physical layout of data. The usual advice when you start building a compiler in Rust is to avoid pointers and use indexes. Oh yeah, I've really always hated that. I'm not gonna lie to you. The whole like use indexes for everything in Rust to be able to do anything with like tree-shaped or graph-shaped data, it's just such a pain in the ass because now you have to like, it's just extra data you have to keep around that has to be updated, and any mutations can cause oddities and all that kind of stuff. Indexes are great. No, they're not. In large code bases, they allow greater decoupling. Side tables can stay local to relevant modules, improving performance. An index is a U32 and a nudge you towards a struct of arrays layout. Okay, I agree with this. The entity component system style, great. We're on team. I'm on that team. Sort of. A more flexible computational strategies. Indexes are easier to serialize or plug into incremental compilation frameworks, but they do make programming in the small significantly more annoying, which is a deal breaker for hobbyist tinkering. Well, I mean, the problem is if they're programming in the small, the problem is that your program is one large programming in the small. Like at the end of the day, it's just one big ass programming in the small. And so you just deal with indices like until you can do the wrapping interface around it to where you don't know about the indices. Like that entire thing is just one ass pain. But OCaml is crufty. Is it? Is there something better? Is really OCaml crufty? My brief exploration into OCaml says that I could be very excited about OCaml. Sure, I may not be using stuff in production, right? We're pretty close to Haskell at this point. Probably not production, right? Probably not going to be using it for production, but my small little LSP file parser, I really enjoyed it. Like, I genuinely enjoyed building that in OCaml. Today, I realized that TypeScript might actually be okay. Several question marks. It is not, let's see. It is, okay, sorry. It said TypeScript being okay. I'm having a hard time, processing that. So my reading skills just went down the window because just a little bit earlier talked about like just works build systems up here, okay? It's emotional, right? I'm just emotional for a second, okay? It is not really surprising given how the language works, but it never occurred to me to think about TypeScript as an ML equivalent before. So let's just write a tiny TypeScript type checker in TS. Of course. So we start with Deno. Everybody loves Deno. Am I wearing my Deno hoodie? Is this a Deno hoodie? No, that's not a Deno hoodie. See a love letter to Deno. Ooh, wow. Deno, I love you. Oh, Deno.
Oh, Deno. Oh, Deno. Deno, I would just like to let you know that I think you are very, 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 very beautiful. Deno.
I'm not sure what just happened there. Honestly, I don't know what just happened there. I think I made a mistake. I agree with you. I do. I genuinely agree with you, Karen. I will not do that again. Okay. Can you get up? Can you write a letter for me and just say sorry to all the $5 a monthers for what I just did? Thank you, Karen. But the TLDR is that Deno provides out-of-the-box experience for TypeScript. This is a pain point for OCaml, and something that Rust does better than either OCaml or C++. I'm pretty sure OCaml at this point is pretty much straight out of the box, isn't it? My wife does not know about my Deno face, okay? She doesn't. Real talk, I think because Dune and OPAM just like, you just install what you need and you get running, you know what I mean? But Deno does this better than Rust. It's just a single binary that comes with linting and formatting. There's no compilation step, and there are built-in task runners and watch mode. A dream setup for quick PLT hacks. Okay, fair. I see what he's trying to say is that it's just so simple. There's no anything to it. And then there's TypeScript itself, which it's a sufficiently flexible yet lightweight ceremony type system. Okay, that's a fun way to kind of describe TypeScript. So that's a fun way. I like that. Let's start with defining an AST. We're hacking. We won't be bothered to make it an IDE-friendly concrete syntax tree or incrementally friendly, only store relative offsets tree. And we'll just tag AST nodes with location. Okay, so there you go. Location's a file, line, column. Even here, we already see high-level nature of TypeScript. String is just a string. There's no thinking about the usize versus U32. Okay, can we all agree that this is just the world's worst thing in the universe? Technically correct, the best kind of correct? Can we all agree that whenever, like the LSP I'm dealing with right now, when you get an LSP message, the line and character offset is U32, so when you're actually using it, you have to convert it to a usize, use it, and then you have to go back the other way. It's just so annoying. You're not even on this train? Okay, I can buy that. Usually an expression is defined as a sum type, as we want to tag each expression with a location that represents that would be slightly inconvenient for us. So we split up things a bit. Location, expression kind. Perfect. It's an interface. Always very careful about interfaces because you can actually do collisions. Export expression kind as bool, expression int, all this kind of stuff. This can be super annoying because that means your expression has to be a tagged kind. Like an expression bool has to have an expression. I'm very doubtful of these little T's in here. These T's. Feeling very worried about these T's. The thing is you feel like you're doing the right thing with generics in TypeScript, and often they get so unwieldy and you've made such a mistake. One thing more, as we're going for something quick, we'll be storing inferred types directly in the AST nodes. Still, we want to keep raw dogging and type checked AST separate. So let's see. So what we are going to do here is to parameterize the expression over associated data it stores. A fresh parsed expression would use void as data, and the type checker will set it to type. Here's what we get. All right, we get the T expression type. We got that. There we go. A definition of expression binary could look something like this. Let's see, we got a binary operation, left-hand side, right-hand side. Okay, export binary op. All right, see, there you go. Here's the type discriminator that I was talking about. By having the type discriminator, you have to have this. And then you're going to really fall into this problem with, like, T has to be a pretty dang generic here. Export binary op, which is going to be add blah, 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 blah. Ooh, wait a second. This isn't type. Hold on. This isn't typed. Oh, this makes it really interesting because this is not type discriminated. This is a non-type discriminated piece of data, which means that when you're checking, you can't directly check is bool expression, right? There's no operation here, or there's no type that says is bool. is booling, Boolean. Note that I don't introduce separate types for each. Add expression, sub-expression. All binary expressions have the same shape, so one type is enough. Sorry, I just got stuck on Boolean. But we need a tiny adjustment here. Our expression kind is defined as a union type. To match our value of a union type, a bit of runtime type information is needed. Got him! Got him! I can see into the future. This is where you say pre-read. You say pre-read. This is, come on, please. You're supposed to not believe anything I say. That's like your job, Chad. That's not my job, okay? Thank you. It's kind of ridiculous that you guys are just assuming I know everything. However, it's one of the core properties of TypeScript that it doesn't add any runtime behaviors. So if we want to match one expression kinds, and we sure want, and for sure we want, we want to give a helping hand to the compiler, include a bit of runtime TD information manually. Runtime type information. That's what it stands for. It definitely stands for runtime type information. Definitely that. Rehearse stunt. Tag binary. Let's go. Tag binary means that its only possible runtime value for tag is string binary. Yep. Similar to various binary expressions, Boolean literal and int literal expressions have almost identical shape, almost because the payload, Boolean and the number, is different. TypeScript allows us to neatly abstract over. Bam to bam. This is where it's starting to get. This is where things are starting to get a little bit goofy. You're gonna start hating your life. Where's T used? Where the hell is T? Why is there no T? Wait, what is T? T's not even used here. Finally, the control flow expressions we only add if for now. Is T phantom type? What's T? Phantom type? You're a phantom type. I mean, it's a literal type. It's definitely being used. It's not phantom data. I don't think there's a phantom data in TypeScript. Maybe I'm wrong here. Okay, hey, to be completely real though, just to be completely real, the T is silent, classic T is silent. I don't really understand what phantom data is. I know it's used on one cell, or not one cell, but it's used in ref cell, and maybe one cell and all these other ones. I don't really know what it means. Okay, I know that there's phantom data. I don't know what it does though. Okay, real talk. I don't know what it does. TJ, I hope you're ready for this. Finally, flow control expressions. All right, looks good. Flow control expressions. If exper is if, here's the expression, then branch, else branch. Ooh, what about if then branch? Shouldn't this be like an array of those? I don't know how this works. This concludes the definition of the AST. Let's move on to type inference. Starts with types. All right, type equals type Boolean or type int. Okay, bool, type Boolean. Const tag bool, type interface int tag equals this, type let's go. Okay. By the way, I hate this. I want you to know right now I hate this. What you're doing right here makes it such a pain in the ass sometimes. There's all sorts of problems with TypeScript when you name them the same thing. Our types are really simple. We could have gone with this. But let's do a bit more enterprising. We start by defining different types for integers and Boolean types, as these types are singletons. We also provide canonical definitions, and here are another TypeScriptism. Because TypeScript fully erases types, everything related to types lives in a separate namespace. So you can have a type and value sharing the same name, which is exactly what we want to do. We use for defined singletons. I know you can, but it can be such a pain sometimes, especially if they're not. It could just be a pain. Finally, we take advantage, because there's this one problem where people sometimes will not export the type, but export the constant, and then you can't have the type, but from your functions, you export the type. Sometimes TypeScript gets goofed up on which one is it trying to export from a function, the interface or the concrete type. I've had just all sorts of problems with it. Finally, we can take advantage of our associated data parameterized expression and write the signature of infer types. All right. As it says on the tin, enter types. Fills in type information into the void. Let's define the details. Okay. Let's see. Infer types. We got this one. It comes in with this thing. Expression kind tag. Case. Cass me daddy. All right. There we go. We have all these nice little these right here. There's one problem, though. What we really want is something like inferred type equals switch. Yes, you'll want something like that. But in TypeScript, switch is a statement, not an expression, so let's define the generic visitor. Isn't this great? Isn't TypeScript just fantastic? Need a Primogen bingo card for streams. TJ, what are you saying about me? Prime complaining about names of types and values. Called it. Okay. Shh. Don't do that to me. I don't know what you call this, but I hate all of this in TS trying to figure out what something is, and I find unions of nested types of unions of. Maybe it's a skill issue, but I can never follow. It's not just that. It's also that all of these things that you're building requires pre-watched. Damn it, Ryan Winchester, they're on to us. But not only that, but it also requires a bunch of runtime programming to get over this, right? You don't have syntax to support what you're trying to do. I find that to be the most difficult part. All right, visitor. Here we go. Bool. There we go. Int, binary, if. Okay, good. I like visitors. You know, you got to have that. Visit, T of R, expression T, visitor, T of R. All right. Let's see, return a V, bool, expression kind. Kind. Okay, nice. So this must be the value visitor. Okay. Armed with the visit, we can ergonomically match over the expression. Infer types. Types, const, visit, expression, bool, type bool, that did this. There's those little ones that they were doing earlier. Result type, binary. There you go. The if type, fantastic. Result types. Result type, let's see. Okay, here we go. AST, binary, add. Oh, hey, don't stop the music. Let's see, result type. Okay, so we were looking at this stuff. We're returning out types. I feel like we're still missing the type on the way out, right? It's not inferring the type well enough, I don't think. Before we go further, let's generalize this visiting pattern a bit. Recall that our expressions are parameterized by the type associated data type checker. Yep. All right, where's this? I want to see the thing where it actually makes it into something worthwhile. Because the thing that you're missing here is that you have a type, you do this visit, you do the operations on the visit, and then ultimately what ends up happening is that you have this problem where you still have to do the same check everywhere, right? Like, you don't actually get any syntax or pulling out, right? It doesn't actually autocomplete to something specific. It doesn't actually type narrow. You just have this generalized type that you constantly have to untype into the specific thing constantly. And then not only that, but hey, small critique, creating an object and a bunch of functions every time inferred types are called, you're going to have a really slow compiler, okay? Your compiler's going to be really, really slow. You realize how many times you're going to create this object? It's crazy town, okay? It's crazy town. All right, transform maps an expression carrying T into the expression carrying V by applying an F visitor. Classic T into the V with a visitor. Okay, we all know about this. All right, what does it look like? Transform in a base. We take this one. Okay, yeah. Wait, what's this one? Oh, that's just like a one that's not actually a thing. Okay, confused me there. I was like, wait, what is this syntax? I don't get that. I don't get that at all. We got int, binary. Okay. We're recalling transform, doing all this. So we're building up the tree, build up the entire tree. Now that we have the expression kind in both the expression U and expression V, literals don't depend on this type parameter. And TypeScript is smart enough to figure out this without us manually reassembling the same value with different types. This is where the magic of a visitor VV happens. The code is pretty regular here, though. So at this point, we might actually recall that TypeScript is dynamically typed language, and we write a generic traversal using object.keys while keeping the static function signature in place. I don't think we need to do it here, but that's some comfort knowing it's possible. Object.keys is a bane of my life. Object.keys is one of the banes of my life in any library ever created and is emotional. I don't know why you even have to say that. It should be out. Now implementing type inference should be a breeze. We need some way to omit type errors, though. TypeScript would be trivial to accumulate errors into an array as a side effect, but let's actually represent type errors as instances of a specific type. Type error, pun intended. Banes of life called it. Oh, gosh. Come on. We're not calling anything. This is my life. It's now or never, and I'm not going to live forever, okay? You think darkness is your ally? Bane called it. You guys are calling the strangest things, okay? And you happen to be right. You happen to be right. Type of, key of, object, that just feels so stupid to do, okay? The fact that you have to do this all the time makes me want to, just makes me want to cry a little bit, okay? It's not a love. This is not a love sign, okay? This isn't love, okay? This should be a sad face that you have to do that. Hey, what's your object? It's this defined type. What's its keys? I don't know. I don't know what they mean, right? Like, why do you gotta be that way? All right, inferred types. All right, there's a lot of inferring going on here. Hey, totally cool, but I'm tired of reading code. Very awesome. Astute readers will notice that our visitor function actually takes a extra AST location argument. TypeScript allows this argument only in cases where it's needed, cutting down verbosity. Okay. And that's all for today. The end result is pretty neat and concise. It took some typing to get there, but TypeScript auto-completion really helps with that. So I'm gonna give a little something here. Here's my big problem with TypeScript here. Did you see all the work that was required to create these types? There was a lot of work to create these types. Remember this whole production ready thing? This is my problem with TS. TS actually looks more like this. Okay? TS right here, the T and the S, like this. Here's the problem with it, is that when you're working with TypeScript, you find yourself programming a completely separate flow of logic, right? Just like a completely separate line of programming. And that one single set of programming you have to do with all types. And then once you're done, you then go and you then program your actual program. And when your program needs to change, you need to go over to your type system and figure out why your types aren't doing what they're supposed to be doing, right? You know what I mean? Like, it's just this super annoying kind of like, it's, I'm not sure, it's like, it's bimodal programming. I'm not sure how else to describe it other than that. And that's really frustrating. Whereas it does seem like in the OCaml world, OCaml doesn't seem to have that problem because you effectively can infer everything about the type system through and through. So when you make a change, it makes the change to the types through and thus leads you to just knowing where you've goofed up the type as opposed to having this completely separate vertical of just type programming. You know what I mean? I wouldn't call it bipolar. I'd call it bimodal. Bimodal, right? Because it's like you have to have a type track and you have to have a programming track. And the type track is purely so you don't screw up the programming track. But the type track can be very unwieldy and sometimes super annoying. So there's like this level of knowledge you require. The thing about TypeScript that makes it so interesting is that it is super powerful types. It's like you saw, that's a super powerful language to program in. You can do quite a bit with it, but there's like, you're good at TypeScript and you pretty much plateau at your goodness. And then there's just like, it's a non-differentiable function. And then for you to get any better, you pretty much need to go here because this little spot in between these two means you program pure shit. Pure shitty types, okay? This is a portal, all right? This is a portal. We'll go here and we'll go here and just go right here, all right? This is a portal right here, and this portal happens to go to this other portal that I was just drawing right over here, which looks like this right here, and we're going to jump in here, and we're going to go back to that nice blue I had, and then we're going to go back down here, and then go back over here, and let's make it a little bit more orange. There we go, and we're going to take it, and see, and you're going to come right out of here, and guess what's down here? Guess what goes down here? Hell. Actual hell exists down here, okay? You go into here, you go through here. This you're probably pretty still fine at. This you're pretty still fine at, but there's only one person that can work on this thing, and so your life is just absolutely scumbag. Or you have everyone that can work on this part. But then your type system kind of sucks, and you just have any's everywhere, okay? You just have any's. That's your life. A bunch of any's. That's just what happens. You have any as user. You know why? Because you can't be bothered to program for 3 days such that this just works automatically. Instead, you know it is. You know it is, so you do that, okay? This is why TypeScript can be very, very difficult. I smile like the Terminator, don't I? I think I smile like the Terminator. The name is, I mean, it wasn't that bad. I mean, TypeScript, it was a pretty cool little type system. that was made for the compiler, and I totally agree that you can do it. But I want to ask you a question, a quote by old Jeff Goldblum. Just because you can doesn't mean you should. I know I screwed up the quote. It was like they're too busy to see if they could to ask if they should. I get it. Okay, I get it. But I'm just saying. Again,